focus on the negative exponent, building on skills from 7th grade. In order to rewrite this expression so that the exponent is positive, I write the reciprocal of the base, and then the exponent becomes positive. So to do a few basic examples, something like number 2, the negative is only being applied to the m, so the 3 would stay on top. It's 3 over 1. Something like number 3 rather, the 7 and the b are fine where they are, and then the a would move to the other side of the fraction bar. Let's see, we'll do a few of these together. Number 4 is basic but interesting. You adding these together, 7 plus negative 9 is negative 2, and then to take it one more step and rewrite so that all the exponents are positive, you would put it on the other side of the fraction bar. Let's go down, let's look at something like number 8, number 9, where we're starting to apply some of the newer properties and things are layering up just a bit. Number 8. In number 8, you would have options here. 2 ways to do this. One way, you could apply the negative sign individually, and then in the next step, you would move each to the other side of the fraction bar. 8 squared, I'll keep it in exponent world and then I'll clean it up in a minute. 8 times 8 is 64. So that would be your simplified expression for number 8. An alternative way for doing number 8 would be this. I'll do it in blue. There's another way to think of number 8. You could simply take that entire expression in parentheses. And I'm only doing this is only affecting the exponent on the outside. So the 5, moving to the other side of the fraction bar, the 5 encased in parentheses is not affected by the move to the other side of the fraction bar. This move is solely to take care of the 2 on the outside. And then I would go on and apply as I did before. I would have the 8 squared, p to the 10th, and then take it to the next layer. And you end up in the same place. Same place, 2 different ways to get there, 2 different ways to arrive at the same result. And let me erase this. And here in number 9, same type of thing, same type of thought. In number 9, you would have choices. You could take the entire expression, move it to the other side of the fraction bar. The sole move, or the sole reason for that move, is to take the negative 3 on the outside and make it positive, and then you would apply the cube to each member inside the parentheses, and you would end up with 125 y to the power of 6, or changing ink colors to give you the other option, or you could simply apply the base of negative 3 to both as it is, and then rewrite it, putting both of these over 1 so that the exponents become positive, and then of course you would cube the 5 and you would end up in the same place. So options for doing this. And let's look at number 10. I think number 10 is interesting. So let's look at 10 on the video. And then I may stop this video and just let you start working on a few things together. I've got a few other things I would like to point out, but I want you to just start practicing. So in number 10, I've got the negative inside the parentheses, and it's tempting if I choose to write it like this, which is the way that I would prefer to do it. I'm going to bring this entire expression to the other side of the fraction bar, and the reason for that move is to make the 4 on the outside positive. And then I'm going to apply this one at a time to each member inside the parentheses. So 1 remains, and I'm going to raise 3 to the power of 4, which is 81. And then I've got r to the power of 4, and then s is to the power of negative 12. If the instructions say rewrite so that all exponents are positive, number 10 really looks like this. S to the 12 comes to the top, and then 81 and R4 remain in the denominator. Another way to think about this, if that's confusing to you, here's an alternative way to think about this, and it might make it easier to understand. If I apply the base of negative 4, the way it's presented, when I come to the s, notice I've got -3 times -4, making that positive, making that exponent on the 12 positive. And then in the next step, I would rewrite, and the S12 stays on top, and then the 4s, the two 4s become positive when they move to the bottom, and you end up in exactly the same place. And I do think that's a little bit confusing when you're first learning, but two ways to look at these expressions where you've got the power and the product outside the power. So the power on the outside is kind of taking over for the moment if it needs to be written as a positive number. And I just wanted to point that out on the video. A few other things before I stop the video, but not much else. Let me look through the notes and see what else I have. Things just start to layer up a bit. Let's look at number 20. And in number 20, I've got pretty much every property coming together here all at once. And probably what I'll do, I think I'm just going to take this expression and I'm going to put it on the other side of the fraction bar, and I'm going to make that 2 positive, and I'm going to do the same thing here, making that 3 positive. And then I'm going to clean this up from here, and this is going to give me, I've got, wait, let's see, that's a 3, I wrote an X. And this is going to give me, let's see, squaring this, okay. So I've got, let me see, let me move over here where I've got more white space and I can see what I'm doing. So I'm taking this and I'm now going to move over here for the next step. So I've got 1, I start with the coefficient of 16, and I have x 6, y 12. And then I'm going to add this 2, adding these together. And this is going to give me, let's see, this gives me 8, x 6, and y 14, or y 12 rather. I can't add these together because I don't have common denominators. And what I would need to do with this in order to be able to add these together, I would need to get a coefficient of 16 right here. So I'm going to multiply this by 1 over 2, or 2 over 2 rather, in order to give myself the common denominator for adding these two together. Notice that I'm covered on my variables, but with the common denominator piece, that's what I would have to do. So the simplified expression here, and that's a multiplication. The simplified expression here, my numerator is going to be 3, my denominator is 16, and then x and y with the 6 and the 12. Let me see if there's anything else interesting on this topic. I feel like this is more of the same. And the maze includes everything, all of the properties together. And this is a rather interesting property set right here, or problem set right here, illustrating just a little bit of everything. And the things that are catching my eye here, number 9, this is really just 2x cubed. And number 13 is really just x to the power of 8. Raising anything to the power of 0 is just 1. And let's see if there's anything else interesting. Number 18, probably what I would do with number 18 is take that base and flip it, and that would make that power positive by just writing the reciprocal, just flipping that base right there. And then I would apply the exponent and carry on. I think everything else is probably pretty straightforward. You can handle it. Those are the things that just kind of caught my eye the most. And I think I may stop this video here.